Select the best set of reagents to accomplish the following transformation. So when approaching a problem like this, we want to look at what is our starting material and what is the product that we are trying to form. So we can see here in our starting material that we have an alkyne. We also have a benzene ring, but we see that the benzene ring is not changing, which is not surprising. We haven't talked about benzene ring chemistry yet, but we have said that it's not as reactive as a normal alkene. It's not going to do the same reactions that we saw in our alkene reaction chapter. So I would classify this mostly as being a terminal alkyne, an alkyne at the end of the chain. And I can see that, and we also have, we'll go ahead and label the benzene ring or arene. So we can label that. We see that that's not changing, but where we do see the molecule changing is here. So we see that this is going from being an alkyne to an alkane. And hopefully we also see that we've got some extra carbon atoms. And so I like to number my carbon atoms when I'm counting them. And when I do that, I'm not going to bother numbering this benzene ring. I can see those 6 carbon atoms very clearly. I can see where they are here. I can see where they are in the product. I'm going to focus on what is changing, which is the part that's the substituent on the benzene ring. So in the starting material, I see that I had 2 carbon atoms that were attached to that benzene ring. And I can see here that I still have those 2 carbons, but I also have 2 more. So I have added to the carbon chain. So that means that I need a reaction that will form a carbon-carbon bond. And at this point in our studies, we only know one such reaction. We know this. We know that we can take a terminal alkyne, treat it with a strong base, and the typical strong base is sodium amide. And then if we attack an alkyl halide, we can add to the carbon chain. And so this is the general reaction, and we can tweak the length of the carbon chain by changing what our alkyl halide is. The only stipulation about this alkyl halide is that it cannot be very hindered. So it needs to be either just a methyl halide or a primary halide in order for this reaction to work. So if we're adding 2 carbon atoms, that means we probably need an ethyl group. And then we need a strong base to add that ethyl group. So we're going to have to do this carbon-carbon bond forming reaction first. And I say first because we can see that the product here has an alkyne, right, of this step. But here we do not have an alkyne, which means we're going to have to reduce that alkyne. But we're going to have to reduce it after we've added to the carbon chain because we need this acidic proton in order to do this alkylation reaction. So what we can see then, hopefully see, is that our intermediate that we need to have in between these two is going to be the alkyne. So there's the 2 carbon atoms of the alkyne, and we need to have added 2 more carbons. So you can see 1, 2, 3, 4. And then we can do the reduction to get the alkane. So in this first step, we need to use a strong base, so sodium amide. So there are other bases that you can use for this. A carbanion would also be strong enough, but that's about it. Right, something like sodium hydroxide that we see appearing in one of these options, sodium hydroxide is not a strong enough base to react with the terminal alkyne. And so we need a 2 carbon atom chain. So that means that we need a 2 carbon atom alkyl halide. So something with 2 carbon atoms and say a bromine, okay? So this portion here is going to come from a 2 carbon halide, alkyl halide. So in terms of your halogen, that could be chlorine, it could be bromine, or it could be iodine, okay? And you won't be having to make a distinction between those. Only one of those would be an option that would show up. And then, okay, so after you've done this, after you've added to your carbon chain, you need to ask yourself, well, how do we take an alkyne and reduce it to an alkane? So we're still going from an alkyne now to an alkane. So we need to add hydrogen across this triple bond. So we know normal hydrogenation conditions, and that will take alkynes to alkanes or alkenes to alkanes. So that's actually what we want, is just our typical hydrogen gas and palladium on carbon. The other two conditions that we saw for reducing alkynes were ways to take an alkyne and stop the reduction at the alkene stage. But since we see that our product is fully reduced, we want to make sure we use the hydrogenation, hydrogen gas and palladium on carbon. So we can see that this corresponds to option D.